Okay, in 5.3 and 5.4, we're just doing a bunch of examples. We're just going through and doing a variety of different questions. So I'm going to do two examples, one using a tree diagram and the other one using a table. And both of these are independent events in both examples. Um, kind of be aware of the definition of random. Whoa, speaking of random, where'd that come from? Um, that's very interesting. Okay, so be aware of the term random. Um, it means the same, but can be applied to lots of different contexts, including probability. So I'll let you do your thing with that. Now, example 1 says a coin is flipped. Okay, a coin is flipped, and a spinner with 5 equal parts or sections is spun. Okay, so those are two things. That's all I need to know right now. Okay, so coin is flipped and a spinner with 5 equal sections is spun. Okay, now this is how I'm going to organize it. And there's a couple different ways. There's not just one way to do it. I'm going to do the outcome with the greatest number of possibilities first, just because it's a little easier to draw. So I have run, I have skip, jump, twirl, and twist. Okay. Now, regardless of what I spin on that spinner, it doesn't affect the flipping of my coin. So if it landed on run, I could get a head or a tail. If it landed on skip, I could get a head or a tail. Jump could be head or tail. Twirl could be head or tail. And twist could be a head or a tail. Okay, see how we're combining all of the putting all the combinations together, all the possible things that could occur when you spin that spinner and flip that coin. Okay, these are all the things that could possibly occur. So now I got to write the sample space. Let me pick a different color here. Pens, whoops. Let's go orange. Okay, so my sample space. I can run, and with a head, I can run and a tail. I could skip. This is where it gets a little long, right? Skip and a head, skip and a tail. I could jump with a head. I could jump with the tail. I could twirl with a head and twirl with a tail. I could twist, whoops, with a head, or I could twist with a tail. Okay, so that's my sample space. I had to draw it out, right? Those are all of my possible combinations. Okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible combinations, which makes sense because there's 2 possibles with the coin and 5 with a spinner. 2 times 5 is 10. Okay, so there's 10 possible outcomes. Now, in B, it says, what is the probability a student would flip a head and spin and land on jump? Okay, so probability is favorable outcomes over possible outcomes. So our number of possible outcomes we already determined is 10. How many of those is a head with jump? Well, where there's jump, I'm going to switch my color again. There's jump and there's head. How many of those are there? There's 1. So our probability is 1 out of 10. Okay, and if we're doing our ratio, it's 1 to 10 or 10%. Okay, there's one example. Second one. A marble is randomly selected from a bag containing 1 blue, 1 red, and 1 green marble. Okay, so there is 3 there. A bag containing 3 marbles, right? And then a 4-sided die is rolled. Okay, so now we got to create a table. So I'm going to do the bag. I'm going to do the marble. So I'm going to go blue, red, and green. Okay, and then my four-sided die, it can be a 1, 2, a 3, or a 4. Not bad, hey? It's as simple as that. This is our marbles. And I didn't leave enough space up here. This is our die. Not pi, but die. Okay. Okay, let me just switch colors. Okay, so regardless, these are independent events. So I could spin a blue, a red, a green. Sorry, that's marbles. I could pull a blue, red, or green marble. And when I roll my die, I could land on any of those numbers. So I could have a blue with a 1, a blue with a 2, blue with a 3, blue with a 4. I could have a red with a 1, red with a 2, red with a 3, red with a 4. Or I could have green with a, with a 1, green with a 2, green with a 3, green with a 4. Those are my total number of possibilities. 3 times 4. What's 3 times 4? 12. So that's our total number of possibilities. So let's answer a few questions here. It says, what is the probability of choosing any color and rolling any number except for 3? So our total number of possibilities, or sorry, our possible outcomes is 12. Now, any color, so green, red, or blue, okay, but anything except for 3. So we don't want the 3s. We don't want this one. So we can have blue 4, red 4, green 4, blue 2, red 2, green 2, and blue 1, red 1, green 1. So that's 3, 6, 9 out of 12. Okay, and then you go ahead and do your ratio. Whoops, 9 to 12. And as a percent, that's 75%. Okay, what is the probability that you're going to go blue or green? So blue or green, and a number greater than 1. So here we've got, in this row right here, we've got a number greater than 1, blue, blue 2, blue 3, and blue 4. And right here, we've got greater than 1, green 2, green 3, and green 4. So that's 1, 2, 3, 4, 5, 6. So that's 6 out of, again, our possible number of outcomes is 12. So that's 6 to 12, or 50%. Whoops, sorry, 50%. Okay, what is the probability of black with a 1? Are there any blacks? No. So we have, hey, our total number of possibilities is 12. We have 0 out of 12. 0, 12, and that's 0%. There's no chance that we're going to have a black with a 1. Okay. How many more do we have? Oh, okay, this is the last one. Okay, so we can squeak this one in. It says, what is the probability that a red or green, okay, I'm going to mark this up good this time. I'm going to pick a different color. Come on. And go green. Okay, what is the probability that a red or green or blue marble is selected and the die displays a 4? So I want blue, red, and green with a 4. There's a blue with a 4, red with a 4, and green with a 4. Okay, so my total number, let's just write it up here. My total number of possibilities is still 12, and we've got 1, 2, 3 out of 12. And our ratio is 3 to 12. Whoops, 3 to 12. Come on, Frankie. 3 to 12. And if you worked out the percent there, it would be 25%. All right, there's 2 examples for you. Soak it up. Watch it a couple times if it didn't make sense to you the first time.